Assalamu alaikum. This is question number 2, part part 10 of model paper, secondary chemistry model paper. So, what is question 210? 210 is these are the 4 marks question. Remember that. So, give the mechanism of free radical reaction between methane and chlorine in presence of sunlight. Or you have to attempt the question, define chiral carbon and plane polarized light. Explain optical isomers with example. तो पहले हम इस क्वेश्चन को जो डिस्कस करेंगे। तो इस क्वेश्चन क्लास में आपको कोई एक ही क्वेश्चन अटेम्प्ट करना है एग्जाम में, अगर जो है आ जाता है इस तरह से। लेकिन हम यहाँ तो लाजिमी सी बात है कि दोनों डिस्कस करेंगे। तो पहले हम डिस्कस करें इसका फर्स्ट पार्ट के मैकेनिज्म ऑफ फ्री रेडिकल रिएक्शन। और फ्री रेडिकल रिएक्शन हम इसको डिटेल यहाँ पे हेडिंग में मेंशन करने की जरूरत नहीं है कि अंडरस्टूड है कि क्वेश्चन में क्या लिखा हुआ है, वही हम एक्सप्लेन कर रहे होंगे। तो इतनी हेडिंग काफी है, मैकेनिज्म ऑफ फ्री रेडिकल रिएक्शन। एंड देन वी शुड राइट कि व्हाट इज अ फ्री रेडिकल मैकेनिज्म. The reaction between methane and chlorine is initiated by an atom or group of atoms having unpaired electrons called free radicals. So we need free radicals. So the first statement says that we need free radicals. The mechanism of the chlorination involves the following step. So if free radicals are uh, required, so the first step is initiation, which generates free radicals. Propagation, when the free radicals interact with the target molecule, then number of reactions can occur over there. And finally, if we want to terminate the reaction at any stage, then the termination uh, is carried out. So first we will see the initiation. In initiation, we generate free radicals. So as we need chlorine, so chlorine free radicals, so chlorine free radicals are generated from chlorine molecules. And this is called the homolytic fission. The way that generates free radical of chlorine is homolytic fission. Why it is homolytic fission? Because when a molecule is there, then there are two electrons. No, you do not need to draw the dot cross structure, but for explaining to you, I am drawing this. So in this reaction, what happens? One way is that both the electron pair during the cleavage, during the bond breaking, both the electrons goes to any one of the atom. But here, one electron goes to the one chlorine atom and another electron goes to the another chlorine atom. So this is shown by half-headed arrow. This is the standard representation that shows the transfer of only one electron. So we use this half-headed arrow, and as a result, it generates two chlorine free radicals. We don't need to show the lone pairs of electron, just one dot is enough that shows that these are the free radicals. अगर आप यहाँ पे मेंशन भी कर देंगे, लिख देंगे तो बहुत अच्छी बात है. It's good to write free radical like this. So chlorine free radicals are generated. Next step, as you have seen, that next step is the propagation, where in propagation, chlorine free radicals attacks the hydrogen atoms of methane molecule to form hydrogen chloride, and methyl free radical is generated again. So see, first what happened, that chlorine free radical attacks on the hydrogen, and as a result, homolytic fission occurs here, that both one electron goes to one atom and another electron goes to the another atom. So this way is called the homolytic, that the distribution of electron is same during the bond breaking. So again, what happens? First, HCl molecule is generated by combining H and Cl, while another one is the methyl free radical is generated. This is called the methyl free radical. Methyl free radical. Now the process continues. The methyl free radical attacks another chlorine molecule to yield methyl chloride and another chlorine free radical. See, so now this chlorine free radical attacks on one of the chlorine atom, and as a result, homolytic fission occurs here, and as a result, first the methyl chloride is obtained and another chlorine free radical is obtained. As you have seen here, everything is written in the text as well. And this reaction continues until all the hydrogen atoms has been removed. But if we want to terminate, then the another step, as I've told you, that these propagation steps are repeated again and again until all the hydrogen atoms are replaced by the chlorine atoms. So if we want to terminate this reaction at any stage, so what we will do, this stage is called termination. These involve the formation of a stable molecule by combining the free radical. Remember that free radicals are not stable, that's why they are very reactive. And the main reaction, that's why this reaction is the chain reaction, is the continuous generation of the free radical. Free radicals are continuously generated over there. So if you want to stop, we can introduce more free radicals in the system. So what happens? Then there are more chances of collision of free radicals with the free radical. So when a free radical combines with a free radical, for example, if these two free radical combines together, they produce a chlorine molecule. So we do not need to draw the arrow here because both are free radical, or if you will draw, then no problem. Your mass will not be deducted, but arrows should be correct. And how to draw the arrow? You can draw like this. You can show the attack from any one of this side, whether this chlorine attacks on this or this chlorine attacks on the this, because both are the free radicals. So anyone can attack on each other. But remember that drawing the free this arrow is not necessary. It is not required at any stage. So you can ignore this. Another chance is that the methyl free radical may combine with the chlorine free radical to produce methyl chloride. So methyl chloride or chloromethane is obtained. Chloromethane. Chloromethane is the IPC name, while methyl chloride is the common name. And another chance is that two methyl combine together, they attacks on each other when they collide. So what happens? An ethane molecule is obtained. So sometimes they may give you the reason why ethane is generated during chlorination of methane. So the reason is that because there are number of methyl free radicals. So these methyl free radicals can combine to form ethane as well. Now, inshallah, in next video, we will see the next part of the question.